Hey there, Gnomers! Welcome or welcome back. One of the two. What are we doing today? We're getting our rocket on, baby. Rockets, rockets, rockets. Pretty cool. Well, today, Normally Nomenclatures, we are back out at the Curmudgeon up the tracks from Telkeaton and Chase, and we're doing introduction to rocket stoves and rocket mass heaters. Now, we are going to take this technology and we're going to take it over here and we're going to put it in that shop over there, and we're going to heat up a greenhouse and a shop all at the same time. What do you think about that? Love it. Rockets. That's the way we roll. That's right. We're going to take the technology of rocket stoves, foxhole stoves, Dakota stoves, and we're going to heat some buildings with them. Why? Well, you use about 80% less wood than a traditional wood stove to begin with. The heat lasts much longer because you're storing it in a battery, and it burns 85 to 90% efficient. Not as much smoke. We love that. Let's do it. You ready? Let's go. Come on, people. Let's do something, even if it's wrong. All right, welcome back. We're here at the Curmudgeon Inn. And our friend Rob here's got one of these beautiful little pre-manufactured rocket stoves that you can put stuff on here and cook and do all kinds of stuff. And we're here teaching him how rocket stoves work and how rocket masses work. And he had this sitting here. I said, this is a perfect way to introduce us to what's going on with the rockets. We're going to do a little test here and see if we can get this thing fired up and show you all how rocket stoves work. Now, the big thing with the way rockets work is you've got your J, what they call a J tube or an L tube or whatever you're doing. Basically, this is what you feed your fire and your wood and stuff into. And as it's coming through here, it burns, and as it makes these vortexes in through here, and it super burns all your wood that you're using. So they're very super efficient. You're getting the maximum heat out of your wood. Your wood is burning as clean as possible. And you'll notice this, once this really gets fired up and going, you won't see any smoke come out of here. And that's what's really cool about it. This way of, well, you want to say cooking, dates back thousands of years. The Dakota Indians used this type of cooking method because it was low smoke, very efficient. But they call it either a Dakota stove or a foxhole stove. And basically what you're doing is they find a foxhole in the side of a hill, and they just dig down into it and put a chimney in there, start a fire in it, and they made basically the same thing, just within the ground. And throughout the years, it's evolved, and to today, we have things like this.
And you add some mass as a heat battery?
Oh, yeah. So that's pretty cool. Now, one thing you want to make sure you do when you're lighting these, especially for the first time when you don't have any heat, it's very important that your heat is siphoning through, coming through. So you want to make sure this gets a little bit warmer. If you're starting your fire down in here, basically what it's doing, it doesn't know which way to go. It thinks this can be the chimney, it thinks this can be the chimney. So when you have cold going into hot, that's what makes it go, and that's what keeps it going. So you got to get that established first. So what I like to do is I'll put a piece of paper in the top here and start it off. That will only do some of it because I need that in the bottom. And basically, if I stick this in here and light it, if I can, that in there. That's getting the upper chimney hot. So we'll start this siphon effect.
Then we can put some paper in here, and in theory, this should light right up. Got our paper. Just like any fire, you want to start off with some kind of fire starter and some kindling. You can see how this is coming up here, and this is actually sucking air down in there.
You can already hear it. And another main thing too is this right here is for as you're burning this, you can let more oxygen in as you close this. But when you're starting these type of stoves up, you want to make sure this is closed if this is all the way open. It's a balancing act between these two. And you can already see it, it's going up and in. And once that wood, which is already starting, because it's sucking air. See that in there? We'll get the camera up here and show everybody. So basically what we're doing is we got our fire starting down in there, and it's going, and our air's going in here and coming out there. Because we heated the top up here first. We let it know what the chimney was. Yeah. You can, which I might not have put enough paper in there to get the wood started. In fact, I didn't. So you mind getting us a little more paper. We'll try this again. It's being a little bit fickle. Yeah. Another thing too is people start the fire down this way. You know, they'll put their wood in there so it keeps going. All right, we're gonna mess around with this a little bit, and we'll come on back. Here we go. It's going now. You can hear it now. You can start feeding stuff down in the bottom there, Rob. And the reason we call these rocket stoves is because once they really get up and going here, you can hear them. They'll start sucking. That sounds like a rocket engine. But we got this thing firing pretty good. Let's create some good heat. No smoke coming out of it. Basically, when you're doing these, you want to control the amount of air that's going through here. It's actually being dampened by the wood that's in here itself.
So this lid really isn't doing anything, it's helping prevent sparks and stuff like that. So basically what you want to do is, if you put the more wood that you put in here, it closes off the amount of air that's going in there. So you start opening up this. And it's sort of it's a fine line that you have to play with, because if you open this up too much, the rocket slows down and the smoke starts coming back up here, as you can see. Shut off the amount of air coming in there. It's going to want to suck more air into here, which all draws up into there.
And once you figure out how to do the dance, these things are incredible.
Oh yeah, rocket baby. Can you hear it?
All right, we love testing temperatures around here, so Rob's got his little thermometer. Getting warmer, getting warmer. Oh yeah, see how fast it jumps up?
600. Average is over 500.
What's the max on your temperature?
647 is mine. 650, 668, 679, 680, 685 is the highest I've seen. 690, 713.
And that's the metal on the outside.
Yeah, 733 right there.
Yep.
Wow.
And that is your sweet spot on the stove. This is where all your reburning is going on, is in this section right in here. And that's why you're getting those higher heats. Because it's not just burning the wood that's going in there, you're reburning the gases.
This has only been on for less than 5 minutes, no, less than 10 minutes.
Less than 10 minutes. Well, I got 8 minutes worth of recording, and
That's
so
including starting.
yeah, so about 4 minutes.
Yeah. That's off $85 Amazon Prime.
Yeah, 85 bucks for this thing on Amazon. And if if it's working right, these will start self-feeding, or you just push them in there a little bit, and you can put stuff in here 6-10 feet long if it's if it'll self-feed.
Yep.
It just keeps going in and feeding it and going in and feeding it. Well, yeah, that's how she works. Now we are going to take this technology and we're going to take it over here. And we're going to put it in that shop over there. And we're going to heat up a greenhouse and a shop all at the same time. What do you think about that?
Love it.
Rockets. That's the way we roll.
So, like you said, it's a balancing act.
Yep, it's a balancing act. And it's not a hard balancing act. And yeah, Rob was just noticing here when he looked in there, when he's adjusting how the flame starts burning and going down, which it's going down this way and then back up this way. Flames going down. That's against the laws of the universe, dude. In some universe, anyway. But in the rocket stove universe, that's how we roll. Rockets, rockets, rockets. Pretty cool. All right, folks. We're going to do some planning and scheming here because we got to get some heat in that greenhouse workshop out there. Rob needs something to do. But basically, I was just explaining to our friend here basically how a rocket mass rocket mass stove works, which you're taking basically the principles of a rocket stove, which is this section right here. Same principles as we had on our stove outside. Basically, you got your feed right here, you've got your burn chamber right here, and you've got your super burn area right here, which is in the base of that chimney as it's going up. This creates a vortex. All of your gases that are coming off of your fire here reburn, which gives you extra clean, super beautiful smoke. And we'll show you a little bit how this goes, but this is basically a 55-gallon drum sitting on top of that chimney. And what it does, it comes up, it goes over, and all your gases come back down here and go over into your mass. Heat up this mass, and then exit your building. And this is basically your heat battery right here. Alright, so now that we know the basic principles of how a rocket works, let's figure out what we're going to do with your situation over there, because I'll show you some pictures here right now. Every rocket's mass that I've ever seen is completely different than the next one.
You got benches made into beds. You got U-shaped benches. And you got portable benches. Pretty cool. My favorite. TPs, baby. Oh, yeah.
Your basic principles are the same as far as your J-tube and your barrel goes to contain it, to redirect it down into your mass. But masses can be any shape. You can have a bell mass. You can have a tube mass. You can have all kinds of different things. And we'll get into all that. But Rob, basically what you got is you've got a building here. We'll just do the upstairs for now. We'll say this is your shop. I know this isn't the way your roof looks, but that's your shop. And this is your greenhouse area. That's your greenhouse. You're going to have little plants and stuff growing in here, right? Yeah, they don't look like plants, at least not the plants I grow.
Vegetables, yeah, vegetables. We love veggies.
Anyway, so you've got an area over in here that you want to have a shop, and you've got an area over in here that you want to keep your plants warm in the spring when you're starting them, when it's on a cloudy day. Any kind of vegetables that we grew up here in Alaska need warmer soils, like peppers and tomatoes. So they got to be in a greenhouse if you're going to have any kind of a success with those. So what we're going to do here is what I'm thinking is if we take our rocket stove to begin with, which this will be, that's your barrel, okay? And basically over here will be where you do your feeding, okay? So this will come into here and go up into there. That's your J tube that we're talking about.
Right.
Okay. So when it burns in there, it goes back down the outside of the barrel, and we're going to divert it into a mass that sticks out into the greenhouse over here. And if you run a piece of plastic here or put a wall here, basically what you're doing is you're closing this off. And if when you run your fire in here, you run a fire in here for about an hour or two, it's going to heat up this entire mass.
Right.
Keep this mass going 4, 6, 8 hours, depending on how the building itself holds heat too.
Right.
You know, the more the building escapes heat, the faster this is going to escape. But it's still going to be long and slow. So once this fire goes out, you're going to get at least 6 hours
Right.
of warmth in this bench right here. Now, there are a couple of different ways that you can run this mass for a bench. The traditional way when they first started doing these was they ran, and I'll show a picture here, that they'll run a pipe in through here. And basically you come down, go back, and then go up.
Basically, normally you got your rocket stove over here with your barrel. It exits into the pipe over here, which will be your mass over in this section over here. Goes around the corner, goes out your chimney over there.
The problem is when you've got all this length of tube is keeping that clean, because you do get fly ash
Right.
that ends up down in here, and trying to get in here with a vacuum, it's just a royal pain.
Here's an example of what I'm talking about. Partially installed one before they got the bench around. Got your firebox over here. Enters the pipe right there. You got your clean out. Comes down here, around the corner. Another clean out. Down here. And out the chimney. Way back over here. Behind the rocket stove itself. Another thing with all these pipes. You got all these bends. You got lots of drag. Draft and drag do not mix. So, we're going with the bell. We'll show you how that works here in a little while.
So there's a gentleman, and I'll leave a link to his website because I'm going to give all the credit to him because that's where I learned it from, is a bell method. So let's look at a vertical picture of what we're talking about here. Your traditional basically is, there's your barrel, here's your mass. I'm not to scale, sorry. And basically your tube would come down here, your 6-inch pipe, your 8-inch pipe, and it would double back and then exit out through a chimney. And all this would be cob. This cob holds heat, releases it slowly over time. However, what we're going to do is we're going to do the same thing, except for instead of using cob to hold most of our heat, we're going to use air. Just like if you think about with your insulated panel windows, you have an air gap in between the two panes. That's your insulating. That holds your heat, holds your cold, whatever, from transfer. We're going to do the same thing. We're going to have a big pocket of air, just like an air balloon.
Nomers, we all know how a hot air balloon works. Make heat down here. Heat goes to the top, gets stored in the top till it cools down. Then the balloon comes down. Basically, same principle. Check this out.
So instead of having a pipe, we're going to have it open, and I'll show you this way. Let's do a fresh piece of paper. Basically, we have, let's do our rocket stove here. Okay. This comes down. Boop, 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 boop. Okay. All your gases come down in here, and they'll escape into your bench here. Okay. So your bench will come out this way. And basically when these are coming down in here to the bench, you want to dump those gases low into the bench. Okay? Because heat rises.
Right.
And what they're going to do is they're going to come in here and they're going to filter in here and they're going to start creating a big air area right in here. Okay? You want to keep that as in there as long as possible. Not too long, because if it gets too cold, you run into issues with your chimney getting too cold and you have draw issues. So basically when it exits this bell, which is a big open air area, your chimney comes up and it exits low. So as these cool down, they'll come down and settle and then go up there. So you're maintaining this pocket of air. What we'll do on top of this is we'll put a mass an inch of cob, concrete paver stones, whatever you want to use. Flower bed full of dirt. Dirt's an amazing thing for storing. So that will be more of an earth type mass, and then you can set all your plants on top there in your greenhouse. Keep everything nice and warm and everything beautiful. And you'll come in here, you work in your workshop, light a little fire in here, 2 or 3 hours, throw some sticks in there, keep going. This heats up in about 2 or 3 hours, 6 to 8 hours, it'll stay warm.
Very good.
So depending on the day and your outside temperatures and your building temperatures, you can go in there in the morning, start a fire, go out there in the evening after dinner, start another fire. And that's all you got to do. Now, what I'm going to do for Rob is I'm going to go through and I'm going to get a materials list because we need to come through. And I'll show you on the next video as we're doing this because I'm getting ready to do one back at the Gnomestead too. We'll show how to build this firebox, what we're going to use with that. Because this area right in here is a mass, but it's an insulated mass. It's not a mass to hold heat. It's to keep it
Operating properly.
If this is not insulated, it won't operate properly. It'll cool down too much, heat up too much, backdraft, and you're going to have nothing but issues. So this area right here is where we're going to incorporate not just air creep, but we're probably going to do clay and perlite.
Okay.
Because perlite is an aerated rock,
Right.
volcanic rock, so that gives us our insulating air bubbles that we need. It doesn't ever burn, so it's good for using in a high heat area. Because you're looking back in here and this area right in here especially, you're looking at 2,500, 2,600 degrees. That's hot.
Yeah.
And there's not a lot of stuff that will hold up to that.
No.
But clay and perlite will. Do you have any questions?
Not at this time, because you've done a very good job at explaining this to me.
Awesome. Well, I appreciate that. And we'll get into more details for you guys that didn't understand what we're talking about here. And as we're going, you'll pick it up. Plus, I'm going to insert some pictures and give you a better idea. But I tell you what, I've been using this system to heat cabins, buildings, greenhouses for the past 8 years now. They've never let me down. I've learned more and more every time I've built one. As far as efficiency goes, as an example, I lived in a 1,600 square foot house. I put one of these systems in with a bench, and it was a 6-inch system. So it was the smaller, not the bigger. But for a 1,600 square foot house, before we put this in, we had a wood cook stove, and we had a forced air coal wood furnace in the basement. Okay? They work great. They go through a lot of wood. In that house, between those two, we were going through 10 cords of firewood and 4 tons of coal. Just in the wintertime, not even for a full year, just in the wintertime. So between October and March, that's how much we went through between the cook stove and heating the house. Kept the cook stove because that's what we had to cook off of. When we switched over to this, rather than the furnace in the basement, we went down to 4 cords of firewood. In 10 months, not just over the
course of the winter.
Right? And our coal consumption, because coal also worked in that other stove, went down to 2.
That's not bad at all.
If you're buying firewood, that's a hell of a savings. If you're splitting firewood on your, that's a hell of a backbreaking savings. So I say rocket stoves are definitely the way to
You
go.
figure the average price of a cord of wood is between $200 to $300 a cord.
Yep.
So I mean, if you drop that down, I mean, you're saving yourself
6 cords,
$1,500.
$1,500 in savings. Roughly. If you're buying firewood, you're saving $1,500 a year. And a system like this, depending on how much, because we're big on salvaging. We're both Yankees, so we repurpose, reuse, we build. And a lot of this, the only thing we're really going to have to purchase that's going to be the higher expense is your fire bricks that go in here.
Yeah.
We're going to salvage a lot of your 8-inch tubing. It's what we can use is a lot of the round ducting from a furnace rather than stovepipe. All this in here, we got a barrel. How much is a 55-gallon drum? I mean,
got 20 of them here.
You already got no cost there. We're going to figure out what you got around here for making a bench. We'll come spring and snow melt. We'll salvage stuff because this is going to need to be fireproof.
Yeah.
So really, the overall expense, I don't think any system that I've ever built in a rocket mass, in any of the ones I've ever done, have cost more than $300.
Oh wow!
And most of that was in the fire brick. The fire brick and the clay that goes. Everything else I scavenged, like you said, you got barrels laying around here. I always had, stuff laying around to make a bench. If you live in an area where there's good rock, all you gotta do is you can make that bench out of rock if you want to. You can make it out of metal studs if you gotta lay them around. If you fireproof it good enough on the inside, you can even do a wood frame. In fact, I'll show you this here. There's actually one that's they consider a portable rocket mast. Yet the outside is actually even wood. We'll put it right here. So I'll show you guys this right here. This is a wooden bench, but the inside of it's all fireproof. But right there is a clean out, and also acts as where you can warm up your chimney when you're initially starting these things. Because that's the thing, when you first start these things up, getting your chimney warm so you get a good siphon action going on is the hardest. But once you do, and if you can get some heat going in here, it'll happen just like that. So there you go. Well, Gnomers, we hope you enjoyed that as much as we did making the video for you. So if you don't mind, give us one of these down there. And if you want to keep up with what's going on and find out more about rocket stoves, rocket mass heat, geodesic dome, how to live affordably, how to live off-grid, the Gnomesteader way. Well, then you're just going to have to hit that subscribe button. Only the shadow knows. It's right over there. Now, if you're interested in doing a little more hands-on, we are going to be having some classes coming up this summer, teaching about different things. One of them is this rocket mass stove technology. So if you're in the Alaska area or you're planning on being there, come on by for one of our workshops. Here's some information you can give us a holler. Until next time.
I'm a Nomie, he's a Nomie, she's a Nomie, you're a Nomie, wouldn't you like to be a Nomie?
Put your comment down on the bottom.
Click the subscribe down on the bottom, click the like button,
Down on the bottom.
make a comment,
Down on the bottom.
peace out.